In our previous lesson, we have considered the domain of a function, and we considered how we can find the domain of a function. We've used some examples such as rational functions, radical functions, to be able to find the domain of a function. My name is Nana Yawedu, and you can call me Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all the videos on time. In this lesson, we want to look at how we can find the range of a function. So we mentioned that the ranges are the images of the domains of a function, right? So if you have a domain of a function, the images that are formed from the domain of a function, when we put the domain into a function, consists of the range, right? So we want to use some questions to be able to find the range of a function. Now let's consider the questions. So the questions are: find the range of the following functions, right? So we want to find the range of the function f of x, which is equal to 6x minus 3 all over x plus 4. And then we also have another function g of x, which is a radical function, the square root of 16 minus x. We have a rational function f of x as well, which is equal to 4 all over 3x minus 2. And then we have a polynomial function, which is basically a quadratic function, h of s, which is equal to 3x squared plus 5x minus 4. Now let's look at how we can find the range of these functions. So basically, remember that the range, right, if you have a function f of x, we can equate the function f of x to be equal to y. So for instance, if you have f of x to be equal to s plus 2, we can equate the function f of x to be equal to y. So it means y will be equal to s plus 2, right? This implies this, or this is the same as this, right? So let's assume we have a function of this nature and we say that x is equal to 2. Then it means that y will be equal to 2 plus 2. And that implies that y being equal to 4 would constitute the range of the function. So this will constitute the range, right? And then the x being 2 will constitute a domain of the function, a particular domain of the function, right? So with the question that was given, the first question is asking us to find the range of the function f of x, which is equal to 6x minus 3 all over s plus 4. So the first step in finding the range of a function is that you must equate the function to y. So let f of x to be equal to y. So that implies that we have our y to be equal to 6x minus 3 all over x plus 4. And then now we want to make s the subject. So it means that we are going to cross multiply, have y multiplying s plus 4 to be equal to 6x minus 3. Then we expand our expression, so we have xy plus 4y to be equal to 6s minus 3. Then we group the x terms, right? So it means that we are going to have sy minus 6x, right? And that will be equal to negative 3 minus 4y. So we can factorize x out of the expression here, making x to be equal to y minus 6, and then to be equal to minus 3 minus 4y. Then we divide both sides by the coefficient of the x, which is y minus 6, and then divide this side by y minus 6. Now remember that for expressions that are basically in the form of a rational expression, for instance, the domain would be all the members of the real number system, but the denominator should not be 0. So if we put negative 4 in place of x here, it will make the denominator 0 and make the function undefined. The same way, when we are finding the range, we have the range being the member of all real numbers. But when we see this function, right, minus 3 minus 4y all over y minus 3, the denominator should not be 0. So it means that we must take the y minus 6, right? So we take the y minus 6 and then equate it to 0. So it means that we have y minus 6 to be equal to 0. And what does that imply? That implies that y is equal to 6. Then when we are writing the range, we write the range as y such that y is a member of all real numbers, right? Except y is equal to 6. So when we use except, we can write it like this, or we can also write the range as y such that y is a member of all real numbers, right, where y is not equal to 6. So any of these constitute the range. Now let's look at the second question. So the second question gives us g of x. So we have g of x to be equal to square root of 16 minus x, and we have to find the range of this function. So in the same way, we know that for the domain of these functions, there are some values that will not satisfy the function. So for instance, if s is 7, the square root of 16 minus 17, right, would give us -1, right? If x is 17, the square root of 16 minus 17 will give us -1. And negative square root of -1 is not within the defined terms of the real number system. So we can say that let y to be equal to g of x. In this case, let y to be equal to g of x, right? And then it means that y will be equal to square root of 16 minus x squared, x, right? And then we are going to make x the subject. So in making x the subject in this case, we can square both sides. So we square this side, we square that side. So we have y squared to be equal to 16 minus x, right? So we are making x the subject. So it implies that x, when we move it across, becomes equal to 16 minus y squared, right? So it means that this will be our range values, right? All the y's here that satisfy the x here. And we can see that this is a quadratic equation. So therefore, we can say that the range of this, so the range in this case will be y such that y is a member of all real numbers, because there are no exceptions here, right, with a quadratic or a polynomial function. So the range is what? Y such that y is a member of all real numbers. So with the third question, I'll put it here, and then you can pause the video, go through solving it, and then indicate whether you've been able to get the right answer, right? So the third question says that, right, so with the third question, it gives us the function f of x, which is equal to 4 all over 3x minus 2. So find the range of this function and put your solution at the comment section so that we can discuss. Based on what we did with the first one, I believe that you should be able to know how you can find the range of this function, right? Now let's look at the fourth one. So the fourth function given to us is 3x squared, right? So plus 5x minus 4, right? And it is h of x is equal to this, right? So basically, with polynomial functions, we know that the domain of the function are the member of the real number system, all the real number systems. So once the domain are the members of the real number systems, it implies that the range of these functions, right, will be y such that y is a member of all real number system, right? So the range of the polynomial functions here will be all the real number systems. So in this lesson, we have gone through the process of finding the range of the various types of functions, and we've realized that for the range, we are basically looking at how we can find the y values, right? So when we equate a function f of x to be equal to y, we are finding the y values, so all possible y values that makes the function defined under the range. In our next lesson, we want to consider how we can find the zeros of a function. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.